So we're going to filter down the idea of a car taking a circular road. We saw it in the last video, but we're going to filter this idea further, right? Friction was providing the centripetal acceleration. Now what happens when friction provides the centripetal acceleration? When friction acts on the tires, wear and tear happens, right? So to prevent this, many times we have a banking of the road, right? Now what does this mean? See, as many times you would have seen there is the angle. I'm just, drawing it a little, magnifying the angle is raised at angle theta, or the outer end of the road is slightly raised from the inner end, so that the road is banked as the car swerves around the circle. Now this helps the car in preventing friction coming into play too much, right? How does this happen? Let's look at it. So the car, we're trying to analyze that, right? So the car is taking this curve, and we know the forces acting is obviously mg. The normal reaction upward, as the car pushes from the road pushes back with the normal force. Okay, these are the two forces acting. So there is an ideal speed that the car can take such that there is no friction in play, and we call this the ideal speed. And many times the speed would be given there on the banking road, and there's also a maximum speed which a car can take. Okay, so how do you find the ideal speed that the car can take on a bank road to take a circular curve, and how do you find the maximum speed of the car, right? So let's first try to attempt the ideal speed of the car. So in an ideal situation, there is no friction acting. Okay, there's just mg and a normal force. So I'm going to draw the point object over here. So there's an mg acting downwards, there's a normal force here, and since this angle is theta, you can work out that this angle is theta, right? So you can take if you take the horizontal component first, we'll see normal force provides the centripetal force. Okay, that banking allows the normal force to provide the centripetal force. Okay, and we get it as n sine theta is equal to mv squared by r. Right. So there's an acceleration happening in the horizontal direction, which is the centripetal acceleration. There is no acceleration in the vertical direction, therefore we know that n cos theta has to be equal to mg. We divide the first equation by the second equation, and we get tan theta is equal to v squared by rg, and I solve for v, and I get v is equal to root of rg tan theta, where r is the radius of this circle, okay, of the circle, and tan theta is the angle at which the road is banked, right? So this would be the ideal velocity, right, or the ideal speed at which the car can take the banking. What happens if the car goes over this ideal speed, right? The moment it goes over the ideal speed, friction comes into play. Now friction begins to help in the centripetal force. Now the question is, what is the maximum speed that the car can go such that it doesn't skid on that circular, or on the circular taking that banking road? So let's look at the condition there. So the moment you're on the banking road, this is a theta, this is a car, you have mg, there's a normal force, and the speed has gone above the ideal friction, ideal velocity, ideal speed, friction comes into play. So the car is trying to move upward at speed, therefore friction acts in this direction. This is the direction of friction. So I'm going to draw the point object over here. So let's say this is the point object. mg acts downwards. There's a normal force here. And we know that this is theta. There's a friction acting in this direction. This is the normal force. And there's a friction, right? And the friction, there's an angle theta over here. So there are three forces acting on the body, on the car. Now let's try to resolve the forces. Okay, if we were to resolve the forces into horizontal components and vertical components, let's start first with the horizontal component. We know the centripetal acceleration is happening. So in this case now there is two forces, which are one is the normal force, and the friction is going to give you the centripetal acceleration, right? So you have n sine theta plus f cos theta is equal to mv squared by r. that these two forces are going to give you the centripetal acceleration. What about in the vertical direction? In the vertical direction, there is no acceleration, therefore N, the component of normal force is equal to the frictional force component plus mg, and I'm going to write it as N cos theta plus F sine theta, sorry, rather F N cos theta minus F sine theta, because F is on this side, is equal to mg. So these are the two equations. Okay, I'm going to say this is 1 and this is 2. These are the two equations which we can use to, which define the forces acting on the body as the car is taking that banking road. Now we want to find what is the maximum velocity, what is the maximum speed with which the car can take the curve. The condition for maximum velocity would be maximum friction, and we know that the condition for maximum friction is F is equal to mu n, right? That's a condition for maximum friction. So we're substituting that in the second equation. You have mu n cos theta, you have n cos theta minus mu n sine theta is equal to mg, right? So I can take n out, and now I find the normal force is equal to cos theta minus mu sine theta, right? Rather, n is equal to mg by cos theta minus mu sine theta, right? From the second equation, I found normal by substituting for friction mu n. Now I take this and substitute it in the first equation, right? In the first equation, we know that I'm going to take n common out, okay, because friction is equal to mu n. I take n common out, I get sine theta plus mu cos theta, right, is equal to mv squared by r, right? I take n common out, now I substitute for n over here, and n I already, since I got it from here, I have mg by cos theta minus mu sine theta, right? Cancels. I'm going to rearrange it and find for v, and what I'm going to get here finally is v is equal to r comes up here, r g, and this one I'm going to divide by cos theta, so therefore I'm going to get mu plus tan theta divided by 1 minus mu tan theta, right? The whole root would be the value of speed. So this would be the maximum speed with which the car can take the